Hey everyone, it's Miss Bell here from the Science Lab, and I am going to be talking about the rock cycle. There are three different types of rocks in the rock cycle. We have igneous, metamorphic, and sedimentary. You guys talked a lot about this last year as far as in 5th grade science goes, but some examples of igneous rock would be like obsidian, basalt, granite. With metamorphic rocks, you have like marble or gneiss. And then with sedimentary rocks, you might have limestone or shale. And it all depends how the rocks go from one rock to a different rock to a different rock, back to a different rock, just depending on what's happening. Is it melting and cooling? Are the sediments being piled up into layers? Is heat and pressure happening to those rocks? Is weathering, erosion, and deposition happening? It just depends on what's happening and how those rocks are formed over thousands and millions of years. So here we go, the rock cycle. So what we are looking at is a drawing of the rock cycle. It looks a bit crazy right now, but it all makes sense on how the three different rocks, igneous, sedimentary, and metamorphic, can change from one type of rock to another type of rock. And it just depends on what's going on with that rock and where it's located. It might have to have heat and pressure, it might have to have weathering and erosion, it might have to have melting and cooling. It just depends on what's going on with the rock. So let's start up here. Let's say we're on a mountain and there is weathering and erosion and deposition happening to create sediments. Now, we know weathering is the breaking down of rock by either wind, water, or ice, WWI. That might look like rain falling from the sky. That might look like ice wedging, or water either by a cliff or a canyon, or the wind blowing. And erosion is the moving or the carrying of those sediments by, again, wind, water, or ice, WWI. So think of a sand dune. The wind is blowing those sand sediments. Or a glacier. That huge chunk of ice is moving those rocks and pebbles and stones. Or think of a delta being created. That water is flowing from a river downward or downstream, and those sand particles are forming a delta. So weathering has occurred, erosion has occurred, and deposition is the dropping down of sediment in some sort of new location, either on the shoreline or a sand dune or a river. After those particles or sediments have collected, they start layering up on top of each other. And that forms sedimentary rock by compaction and cementation. And sedimentary rock is just the layers of compacted sediments that are cemented together by pressure. So again, you start with the weathering, erosion, deposition. It goes to compaction. That means a lot of pressure. Cementation, you get rid of all the moisture. And then voila, you have sedimentary rock. So sedimentary rock can then be classified maybe in like 3 categories. We have organic, clastic, chemical. When you talk about organic sedimentary rocks, that's just rocks that are the remains of dead plants and animals. Think of leaves, plant roots, bones, shells, algae. Look at this diatomite. That's made from algae. It's microscopic. And this coquina right here, this is made up of different types of shells. Another classification of sedimentary rock is clastic. And clastic sedimentary rocks are made up of pre-existing rocks. So different types of pieces from other types of rocks kind of put together, cemented together, and you get something like this shale right here. Or sandstone is another good example. Or conglomerate. You can definitely tell with conglomerate rocks the chunky pieces that look like they're kind of glued together. And lastly, when you talk about sedimentary rocks, is a chemical classification, and that just means they are formed when different types of sediments kind of come out of a solution. They settle out either by evaporation or supersaturation. So this chalk right here is considered a chemical sedimentary rock, or this rock salt, kind of what we know as like table salt. And as sedimentary rocks start to get buried deep within Earth's surface, heat and pressure is added to those rocks. So the temperatures start rising, and all of the weight from the layers above start adding pressure, and then they start to turn into what we consider metamorphic rocks. Now, metamorphic rocks can be classified into kind of two categories as well, kind of like sedimentary rocks. One would be foliated. That just means that it has a certain look to it, kind of like stripes or layers. It's kind of repetitive layers, kind of parallel, where they look like they're stacked on top of each other. It's different than sedimentary rocks. Take, for instance, this rock right here. It's pronounced gneiss. You can see the layers of that rock. Another example would be slate or schist. And then non-foliated, that just means the opposite. So there's no real stripes looking in, or the rock doesn't look like it has stripes. There's no parallel lines. So that might be an example like this, like marble or quartzite. And when we go from metamorphic to igneous, that just means that the rock is starting to melt. It's getting super hot, going from a solid to a liquid. And as it does that, it turns into magma. Now, the magma, as it rises to the surface, it can do one of two things. It can get really hot still inside the center of Earth, and it begins to crystallize. The magma crystallizes, and that is what we would call an intrusive igneous rock. That just means that those rocks are formed on the inside of Earth. So it hasn't risen to Earth's surface yet. And one example of intrusive igneous rock would be granite. Okay. Now, as that magma begins to rise to the surface, it begins to cool off very quickly. And we would call that an extrusive igneous rock. So the magma rises, turns into lava, and then that lava cools down really quickly. And one example would be basalt. You can see all those different holes, the air pockets, or this pumice right here. Again, small pockets of air because of how quickly that lava has cooled down. And as the igneous rocks start slowly kind of going up to the surface, metamorphic rocks can go slowly up to the surface, sedimentary rocks can make its way up to the surface. It just begins the cycle all over again. So metamorphic rocks can be weathered and eroded, and then those can turn into sedimentary rocks. Or let's say igneous rocks can have heat and pressure added to them, and then they get turned into metamorphic rocks, and kind of so on and so on. So the cycle just kind of seems continuous, just depending on what is happening to those rocks and where they're located. Is heat and pressure being added? Is weathering and erosion happening? Is melting and cooling happening? It just depends.